Okay, thank you. Good evening, everyone. This is Sanghamitra Mitra. Currently, I'm working as a principal solution architect as part of Automation Development Center in Cloud and Infrastructure Service Group, Capgemini Technology Service. I have done my post-graduation from Indian Statistical Institute and then joined the IT service industry, serving the industry for last 20 plus years. In my current role, I'm involved in hands-on evaluation, incubation, solution building, and org-wide implementation and proliferation of various automation-related technology with a special focus of artificial intelligence and machine learning. And for last 20 years, I work with various prestigious international clients like British Airways, Hitachi Medical Corporation, Royal Mill Group, Coke, MetLife, Philips, etc. So in today's session, we are going to cover some of the technology enablers under the umbrella of AI and machine learning, artificial intelligence, such as machine learning, natural language processing, deep learning, and how they can be used to solve the business problem in the domain of infrastructure services. Artificial intelligence, AI, and AI for operation promises to revolutionize infrastructure operations. This set of technologies has potential that can give operators absolute control with a wave of a hand, probably with just a mere wave of a hand or just speaking a command. Indeed, many enterprise vision and AI system that can effortlessly and proactively resolve performance, security, and availability problems. However, the grand reality is that, at least as of today, there are a lot of challenges around the real application of AI ML and their effective implementation. From that perspective, it is imperative to have very clear understanding about the basic building blocks of AI, which can be leveraged to solve the business problem in the infrastructure services, along with its limitations and their corresponding use cases where the technology enablers can realize its business benefit. So from that perspective, in today's session, I'm going to talk about a couple of use cases, such as with the application of numerical analysis, where I will be covering problems like anomaly detection, which deals with statistical analysis techniques to find values in the quantitative data and that deviate from the historical norms. We'll talk about pattern identification, a probability-based analysis of quantitative data that attempts to predict future values given historical trend and patterns through exploratory data analysis of time series data. We'll also talk about correlation engine that takes parallel sets of longitudinal data and identify the cascade of events or condition across interconnected systems. Correlation, which is an integral part or integral to building a system-wide view, and which is very critical and crucial for most ambitious applications such as root cause analysis and some predictive analysis use case. We'll also cover root cause analysis, a complex analysis that seeks to match current conditions with previously observed patterns across structured and unstructured data, which attempts to determine the source of error in a system. And then finally, I'm going to discuss the use cases of natural language processing, where we will see and how natural language processing based technology enablers can be used to detect automation opportunity, or how it can be used for classifying or automated dispatching of tickets in the context of a help desk, or how it can be used for classification of email for automating the process of triaging. So I will start with the pattern detection with time series analysis. In this section, we'll investigate how machine learning can solve IT operation problems, and specifically how it helps with the process of data ingestion and can handle event storm more effectively. Now, what is event storm? Event storm comes about through the avalanche of data that modern systems generate. In a modest size enterprise, an infrastructure can generate millions of events a day. And in raw time series data to do that, and the data volume can increase hugely. And buried in all of this application, heartbeat and authentication fail message, which will be handful of alarms that pinpoint a customer impacting failure and its underlying cause. So, as you can understand, the alert data, which are time series in nature, are required to be closely monitored, uh, and the data to identify trends and patterns through exploratory data analysis. Time series data is a periodic reporting of status data from a server in this particular context, or application reported by a monitoring solution. If all is well, your server may well report that it has 25% of CPU utilization and 45% of free disk capacity, and it will keep on doing it every 5 minutes until you tell it to stop. In another case, there may be around 300 events per metric per server per day, almost every one of which will be reporting, I am fine, there is nothing to see here. So an ops team doesn't need to see this sort of data, correct? They only need to know when something has gone wrong, when something is out of the ordinary. And this is where we step into the world of outlier detection and anomaly detection. So for that, we have to do exploratory data analysis. We have to take the help of exploratory data analysis on the alert data or the event data to identify periodic pattern either through visualization or more in-depth statistical or multidimensional analysis. Through these analysis, we can identify patterns like if there is a spike every day at 6 o'clock in the morning, or maybe every Saturday there is a surge of event. So this exploratory data analysis of time series data is pretty handy tool for related other use cases, which I just mentioned, like outlier detection or anomaly detection. Now, outlier detection and anomaly detection um, are terms that are sometimes used interchangeably. An outlier is a value of a metric that is different from other values of the same metric when you expect them all to be similar. For example, the CPU load on the server behind a load balancer may be expected to lie within a specific range. Let's say CPU utilization fluctuates between 40% to 50%. But one specific time of the day, there is a single server running at 70% of CPU. That specific measurement may be classified as an outlier, which is different to all other server CPU usage. The presence of an outlier may also indicate an error in your monitoring, a value that is so far from expected that perhaps it is not a problem in the system itself being which you are monitoring, but the method itself. However, just because a value is an outlier in one context, it doesn't mean that it is anomalous. An anomaly is where a measurement doesn't follow a historical trend. So our hot running server, while an outlier in the context of similar server at a specific point of time, may always run at 70% because, for sake of argument, it is a master server in a HA group. For that particular server, if the utilization spike to say 95%, that would be an anomaly because it is not following its historical pattern or a regular behavior. So let's detail it little more further. Many times, in fact, most of the time, we set up configuration item which we are monitoring, and we monitor a set of metrics for each of the configuration item, which we're just discussing also, right? And each of the time will be have each of the item will each of the metrics for each of the item will be having a static threshold, and if the value goes beyond that particular point, an alert would be configured. For example, if we are monitoring the CPU of a particular system, we may observe that we configured the threshold as 90%, and if CPU usage goes beyond 90%, an alert should be raised. And This is the way most of the infrastructure assets are today is configured. So anytime the value goes beyond the threshold, we will get an alert saying that some action has to be triggered as a corrective action. That means if the value of a performance matrix of a configuration item goes beyond a certain threshold value, which is configured in the monitoring system, then the monitoring system will trigger an alert. Now, in the last section, the last use case which we discussed, that the alert data are of time series type of a data, right? And we can typically see lot of patterns in that kind of data. For example, every day at 6 o'clock, we get a set of alerts. On further investigation, we discovered that some kind of maintenance is going on during that time. So actually, it is not required to take any action for these alerts. So this type of alerts are example of false positive. While the threshold-based alerting or threshold-based anomaly detection is a good mechanism for monitoring, in fact, this is one of the standard mechanism of monitoring the assets, but we must be aware of the false positive and false alarm. Just because there is an alert, that may not mean that there is a genuine problem. On the other hand, there can be case of false negative as well. How? So let's assume that CPU usage is low. So because CPU usage is low and it is not crossing the threshold, the alert is never generated. So in this case, we are missing the alert, where actually this is a situation where it needs to be looked at. So in nutshell, where you have static alert or alerting system based on static threshold, there may be situation when you are getting alert where you really don't have to worry about. And in another case, you may not get an alert which needs immediate attention. So it is desired to have, instead of having an alerting system based on static threshold, if we can have a mechanism where we can adjust the threshold dynamically. Well, how to do that? Again, we can use or ML based technology enablers can be very handy in this particular case as well. So basically here, we need to have a system which will predict the behavior by applying some predictive analytics algorithm, and based on the prediction, it will adjust the threshold in a dynamic manner. Now, the prediction are to be in sync with actual behavior. Then, even if it goes beyond the statically defined threshold, we really don't need to generate an alert. Also, as part of this prediction, it doesn't give a point value. In fact, it will give a range or a band which consists of an upper control limit and a lower control limit. And if the value goes outside the band, only then we will raise an alert. Now, if we can build a system which will be based on the prediction based on dynamic thresholding, then we can eliminate all the false alarms, whether it is false positive or false negative. And in this case, most of the alerts generated by monitoring systems are then which actually requires attention, not the case of false positive or false negative. Little more detail about the anomaly detection, because this particular use case is a very, very important and crucial use case in the especially in the context of infrastructure services. Now, anomaly detection use data samples to establish values and variances that represent normal operating parameters. That's quite clear to us by now, right? Now, anomaly detection, which is an attractive and prolific technique, primarily for two reasons. One is low data requirements and flexible scope. Now, while anomaly detection will benefit from rigorous data preparation, the preparation is often not required. Some type of data inherently lend themselves to anomaly detection. For example, the numerical data, which typically follows a Gaussian distribution, where the distribution look like a bell curve, for instance. So in this case, no preparation will be required to perform a straightforward statistical analysis to identify values that deviate beyond the threshold normal. Now, there are a couple of different variations we can see for anomalies. One is point anomalies, um, we, which we use for to find instance where a data sample deviates sufficiently from the norm. This is the simplest and the most common anomaly detection. Spikes in utilization of data, for instance, are a common form or common example of point anomaly. The second type of anomaly is contextual anomalies, where we use contextual anomalies to find instance where a data sample differs from the expected state of a common condition. For example, a high number of authentication requests might be abnormal around at 3 a.m., but such an event abnormal at 8 a.m. We are just talking in this example. Security solution often use identity as a form of context to determine that a pattern of activity might be normal for one user but abnormal for other user. The third type of anomalies are collective anomalies. We use collective anomalies to find instances of homogeneous collections that differ from the rest of the collections. For example, all application instances behind a properly configured load balancer should exhibit roughly the same utilization for current workload. But if one instance were experiencing significantly higher utilization than others, that would be a collective anomaly. Collective anomaly occur whenever sets of equivalent distributed elements are exhibiting different reaction to same condition. So collective anomalies can be quite useful in analyzing the distributed system. Now, different methods are needed to detect different type of anomalies, of course. Thus, building an anomaly detection system will require the understanding of both the problem and the underlying data to determine which algorithm is best suited to detect the anomalies of the data. Most commercial solutions will perform this assessment automatically. Uh, Statistics and analytics provide several techniques, like how I was talking about the exploratory data analytics in our previous use case. So those kind of techniques provide several ways to identify these anomalies. Statistical analysis generates a distribution model for the data and compares samples against the distribution. Values that lie beyond the threshold of variance are flagged as anomalies. This statistical approach is interesting because it is an absolute measure. Either something is within the threshold of normal or if it is not. Many of the alternative approach of data analytics are probabilistic. This probabilistic approach will provide both an indication of an anomaly and a confidence factor. So it doesn't only give an indication of anomaly, it also provides a confidence factor along with it. For example, if we recall the case above where an algorithm identifies an unusually high number of authentication requests at 3 a.m., in this scenario, the confidence factor indicates that such activity is 92% likely to be a problem. By contrast, if the same number of authentication reports at 8 a.m. would produce a much lower confidence factor, perhaps only a 2% likelihood of a problem. Because in that time frame, maybe this spike can be considered as a normal scenario, right? Additionally, you need to account for recurrence or seasonability in a system where the time series analysis again comes into picture. Many processes have repeating patterns that depend on recurring events or condition. Ensure that any applications of anomaly, so we need to ensure that any application of anomaly detection accounts for periodic and seasonal events such as an increase in authentication requests near the start of a working day, or maybe end of quarter activity of reporting, holiday shopping activity, and so on and so forth. So when building an anomaly detection engine, we need to measure and define the periodic frequency of any recurrent trends within the system. Alternatively, many commercial anomaly detection systems include automatic detection and characterization of recurrent event patterns. If we don't account for seasonality of pattern, then to be normal recurring pattern can be to be anomalies. This brings us to the other reason why anomaly detection is relatively common. It can be applied to just about any scope of consideration, and given enough compute and storage, anomalous values can be found in any dataset regardless of size and scope. The scope of analysis for anomaly detection is defined by the input data as opposed to the case where the output drives the data requirement. Thus, anomaly detection is unique in the domain of in the area of infrastructure services. It is only the technique that doesn't suffer sharp increase in the data requirement for the increased scope. So with that, let me move to the next related topic of event correlation, which provides an insight into the relationship between anomalies in an interconnected system. So till now we are talking primarily in a single system. Now we are talking the relationship between anomalies in the interconnected system. Local problems often become distributed problem, and understanding the scope of impact of an abnormal condition can help identify the root cause and develop a mitigation plan. This use case is closely related to anomalies, as you might have already understood, anomaly detection that plays a critical role in many scenarios. Uh, Now, correlation engine, what it does to identify correlation, we take parallel set of longitudinal data that can identify either the cascade of events or condition across interconnected system. This is an integral part to building a system-wide view, which is very critical for most ambitious applications such as root cause analysis and some of the predictive analytics use case also. Um, Now, this can be sometimes deceptively complex, but it can add significant value on top of anomaly detection. Understanding the cascade of or inheritance of failure requires an expressed relationship beyond the fact that two events happen at or near the same time of instance. So this is a note of caution. Like, I mean, here just by looking, I mean, sometime maybe two events may correlated, but that when some simple system, it is possible to derive the correlation only based on timestamp, but not all correlations are synchronous. This case will require additional dimensions such as host name or IP address or type of problems across log to identify the relationship between systems. In other cases, such relationship between among datasets may not exist at all. So there are no rules on the form of the durable reference other than it must resolve to the same object across the data stream. In case where the data stream themselves do not contain any such references, the correlation engine will need to define and apply metadata that will allow correlation. Generating and interpreting this layer of topology across monitoring and log data can be quite complex. This complexity is part of the reason why building an in-house prescriptive solution is quite resource and time intensive. Moving to the next use case of root cause analysis, which attempts to determine the source of an error in a system. This is immeasurably more complex than all of the previously discussed use cases which we talked about, because it combines the anomaly detection and event correlation with another dimension of analysis that turns a general unexpected condition into a very specific problem with a very specific solution. Therefore, expect root cause analysis to need same kind of data as anomaly detection and event correlation. The first challenge in root cause analysis system is to solve the anomaly detection and correlation problem. As already discussed, this starts with identifying the pattern in the black box data, that is the matrix data, or the white box data from the log file. The challenge here, however, is that anomaly detection in isolation allows for a focus specification of the type of anomaly, whether it is point, contextual, or collective. But with RCA, the solution ideally should look all type of anomalies across all sort of data. So basically, we need to scale up like anything here. The quality of event or anomaly correlation across system and the data will heavily influence the quality of RCA identification. And one thing we must remember in this case, that not only the mechanism of correlation, but also the operational conditions or configuration required to ensure that correlation persists and it is correct. So it is better to avoid manual specification of the topology, which is a very important part of that entire use case. And we should try to leverage the opportunity to discover or automate the maintenance of topology with techniques like extracting the correlation relationship from an existing IT operational database like a CMDB, configuration management database, discovering the patterns of correlation with an agent-based system that observes connection between system and builder topology, and then finally inferring the relationship from the shared data entities like hostname IP address across the log file. So till now we have talked about the use case of machine learning based on numerical analysis primarily. Now let me focus a little bit on the use case of natural language processing. I'm going to talk about a use case where we will see how machine learning can be used to identify automation opportunity. Let us understand this in little more detail. Let us take an example. Let's say that we had got a new account which is getting onboarded, and we are trying to provide services to them. So in this scenario, can we do some kind of analysis which can decide that what are the different use cases of auto healing would be applicable to the new client? Can you do that? Looking at the historical tickets that has been logged into the account in the past, is it possible to categorize the ticket into some buckets? So that we can find out that maybe 10% of my tickets would belong to application related problem, 20% of the problem belongs to network issues, 30% of the problem belongs to the database related issues, and so on and so forth. So in this case, unsupervised machine learning enables us to identify hidden groups or hidden categories from the textual part. So what it does is that looking at the textual part, or the primarily the ticket description or the ticket name, or analyzing that particular content, textual part of the historical ticket dump, it find out the first of all it find out the hidden groups from the ticket dump. Okay, and then it categorize the data, the historical ticket data, into the identify category through a soft assignment, that is by assigning a probability where each of the ticket would belong to. Now, why do we want to do this? The primary reason for this is that, okay, if it is a database related problem, maybe in the past we have done this in particular automated manner. So ability to provide them our mature solution to this client is much higher compared to the another category, maybe the network category, for which we may not have that much level of expertise, at least at this point of time. So that would enable us to approach the delivery team with a confidence that yes, we have a capability, we have done this in the past for tackling this kind of problem compared to the other categories. And it also enables us to essentially reduce the cost, reduce the effort, and increase the efficiency of the entire delivery lifecycle. So to summarize, if I want to identify the opportunity by looking at the past historical data, we would leverage the unsupervised machine learning based technology enabler to identify first a hidden group by analyzing the textual part of the historical ticket dump and then categorizing the ticket, the new coming ticket, into each of this identified category, so that from that we can map each of the ticket to the corresponding automated component. First of all, figuring out or identifying whether the particular auto healer automation component can cater to that particular group, and then in the process it will help us to reduce the cost, reduce the effort, at the same time increase the efficiency of the entire delivery life cycle. However, this use case, as this use case depends on the unsupervised machine learning, note of caution here, the noise or the error percentage typically is on the higher side, especially compared to the supervised learning techniques, or and of course compared to the rule-based way of classifying the tickets. Therefore, it is a must to validate the identified group and the categorization done by the algorithm um, by a subject matter expert, especially when we are starting with the model. The model is fresh or new and not that mature. And going ahead, as a data scientist and the domain expert work together, the maturity of the model would increase and hence the error would be decreased in a gradual manner. Another pocket where a good amount of time and effort is spent by a typical intra delivery team is analyzing and categorizing a ticket as a new, I mean, in a help desk kind of a system. When the new tickets comes, a lot of time spent for this kind of activity. So analyzing, classifying, and the closure of the assigning the ticket to a specific individual. So in this particular use case, we leverage a multiple AI-based technology, tech enablers, to automate activities associated to with the help desk. That is the life cycle of a ticket. So by using this enablers, again, the effort and time spent by the team for this manual activity can be reduced significantly. So the process kind of started when a new ticket is getting logged into a ticketing tool or ITSM tool. So in fact, the process starts when we get the historical data dump again and create a supervised machine learning model for doing the ticket classification. And then when a new ticket is getting logged into the ticketing tool, so that AI engine, which is based on that particular supervised machine learning model, looks for a set of new ticket in a periodic manner. And as it receives a new set of new ticket, it will apply the NLP techniques along with natural language processing to bucketize the ticket into appropriate category. So this is the first point where we are using the AI-based tech enabler to solve the problems of the health disguise. So for categorizing the ticket, we use machine learning techniques, which looks into the description of the ticket, and based on the keyword present in the textual description, the classifier broadly classify the ticket into three buckets. The first one is a self-service type of a ticket. In that case, it can be resolved by the user themselves with the help of a chatbot. So it will go for a queue for the chatbot or a virtual assistant, where automated mail would be sent to the user with a link to the chatbot, so that user can open the chatbot and resolve the ticket on their own. No human intervention is required. The second category of ticket that supervised machine learning model identifies is the where the resolution call for little more involved effort, but mostly consist of a set of repeating tasks, a standard operating procedure. Maybe an example of user onboarding, where we typically consist of a set of predefined tasks, right? So these are a candidate of robotic process automation. Again, we will invoke the suitable auto healing component over there to take care of those tickets also. So again, those set of tickets also can be fully automated using this this enabler. And the third category are the set of ticket where we need human intervention. So for this category of ticket, again, what we do is that we do one more level of classification, to check that who is the right person for taking up that kind of a ticket. So again, to summarize, here we deployed a set of AI-based technology enabler to assist our help desk team in the infra services to automating some of their automatable activities so that they can utilize their time more effectively, kind of bringing the shift left into consideration. The last use case which I'm going to talk about is about email classification. Something related to the like our ticket classification, which I just talked about. But many cases, many of the monitoring tools which are widely used in infrastructure services, mm, maybe they are monitoring the servers or maybe they're monitoring various network components, create email instead of just alerts, or create the alerts in the form of an email and trigger email when an alert is raised. An email So because email still remain a principal form of communication among the people, because directly then it can go to the people rather than doing analysis and doing the triaging, it directly go to the people. Now, from the perspective of classifying the email into set of categories, which help to perform the triaging in an automated manner, we again we can use various technology and enablers under the umbrella of natural language processing specifically, which can be used very effectively for classifying the email-based alerts. So how to do that? So let us investigate a little more in detail about how to handle the text classification problem in the case of email-based triaging. So if we compare the content of email with a question or alert, which typically it's much smaller in case. Here they have a bigger text as present in the email. So specifically in case of email classification, pre-processing is a very important steps where it should at least address the aspect like misspelling, synonyms, and even email specific pattern and the name entity recognition to optimize the process of email classification. And to reduce the pre-processing, we may focus specifically on email specific pattern and name entity recognition. We can do so also by using regex as part of the pre-processing. Now, once the pre-processing is over, we have to choose a model, machine learning model. In this case, again, we are going to use a supervised machine learning model. And we have seen that, while experimenting with the models, we have observed that tree-based methods such as random forest or gradient boosting decision tree usually gives very good result and we can use them. We have to, but for to use them, we have to transform the input text into numerical vector. So there exist many methods like what to vet to perform such input transformation. And if you want to keep it simple, you can use simpler option like term frequency, inverse document frequency, or TF-IDF, which is popularly known as TF-IDF. However, while using the TF-IDF, that uses, so maybe we need to do some kind of fine tuning over here. So after this step, each email in the mailing training set is represented as numerical vector together with the email labels representing the categories we want to classify each email into. And with that, we can train the model, which will which we use further for the classifying the email, right? And then finally, as part of the full process, we have to use the we have to evaluate the model using suitable method. Now that was our that's a basic way of doing the email classification. Now which can classify the emails which are written in English. Now to bring the multilingual feature to it and to enable the translation service, it can be migrated to a deep learning based systems as well. So with that, I will take a pause. and open the forum to for the question answer. Okay, so the first question is that any structured learning roadmap course for this? I would recommend. There are a lot of courses coming from various organization now, but I personally feel Coursera is has good content. Coursera and Udemy, especially there, you can take your course at your own pace. The second question talk about, can you please quote some of the application or use case in AIML in the manufacturing industry? Yeah, definitely there are a lot. So for example, predictive maintenance is a very important use case, and it goes from like prescriptive, predictive to prescriptive case also. So which is and then we have optimization based use cases, another good example where machine learning is used to a great extent. Second question, the next question goes to, what do services based on companies expect from freshers for the position of a data scientist? Okay, so there you need to have two type of skills primarily. Um, of course, you have to have a statistical background, basic knowledge about the basic statistical concept, the statistical techniques, inferences, testing of hypothesis. That is a must, because without that it will be difficult to implement. And at the same time, you have to have a programming background, especially the languages like R and Python to start with. And the basic concept or the basic idea about the data structure is a must when we are talking about the programming languages. The next question is talking about IIT Madras is the most prestigious and top ranked IIT right now. Wouldn't it be great if the students get a proper scorecard with, one second, proper scorecard with the percentile like other student? Probably, I don't know, I mean, this probably I cannot take up this particular question. I have around 10 years of experience in end user communication field in the infrastructure service division. How much enhancing BSc degree course will be for someone? Will it pull me back in my career? I don't think so, because I many of my colleagues had, come from that particular background. But yeah, you have to upgrade your skill. Probably the same thing which I mentioned earlier. The two key skill set are must. You may learn the basic statistical concept, and you can also learn. You have to also pick up the programming language part. So these are the two main basic building blocks which somebody must have, apart from having some idea about the different type of databases like NoSQL. That is also important, but the first two things are must. Okay, and fortunately today there are a lot of courses and lot of learning material available. There are a lot of online courses available, that lot of part-time courses available. So maybe if you want to have a focused, you want to learn in a focused manner, you can take up 1 year part-time course, which are there for the professionals. Alternatively, as I just mentioned, there are a lot of good materials available in Udemy and Coursera, where you can do the learning in your pace. So that's an alternate learning path. So you can adopt that part as well. Respected sir, madam, since admission process in Maharashtra will be starting, Again, this is a registration related question. Unfortunately, I'll not be able to do that. Can you suggest resources, email classification, or even for time series analysis? Yeah, as I told that for quick learning and learning at a self pace, you go to the Coursera. Most of the things you will be most material for, or learning material for most of the things are available there. So I would suggest you to adopt that particular route. How could the use case infrastructure service overlap cyber security like anomaly detection and growing automation core networking services with the help of? Yeah, that is a very interesting use case of cyber security that probably requires a separate session. That's why I had not covered any of the use cases over there. But lot of applications, companies are I, either adopting build or buy strategy there, because a lot of good products are available in the space. At the same time, some if somebody wants to build a custom solution, some companies are taking the build route as well. But yeah, that is a very, very interesting use case, and it's a very interesting application of machine learning. That's true. What are the prerequisites required to learn AI/ML? Yeah. So again, repeat my answer, which I mentioned earlier. Two main basic building blocks to learn AI/ML. One is the very good command over programming language, specifically R, and more importantly, Python, because Pythons are more getting adopted faster, primarily because a lot of libraries are available there, and especially if you're talking about non-structured data analysis like textual data or image data or maybe speech data, there the libraries are much more richer in Python compared to R. R is more for the pure numerical analysis. That is one part. So that programming language, learning the programming language, especially on a focus to the data structure, that is a must. Second part is you must have a background or thorough understanding of the basic statistical concept, the statistical techniques, statistic like regression or the testing of hypothesis, those kind of, and then maybe some of the basic inferences and statistical concept. Those things are very much required there. I think with that, I am not any other questions, Nikita. Okay, I think it is done from my side. Thank you so much.